Hi everyone, I'm Jeff, CTO and co-founder of Trubrics. Today I'm going to be going through our Getting Started tutorial of the Trubrics SDK. You can see this Getting Started tutorial on our docs on the first page, or you can go and have a look directly in our repository on GitHub, directly in the README. What we're going to be going through specifically is how to create validations with our model validator object, and also looking at collecting feedback from a user with the feedback collector. So the first thing you're going to need to do is pip install Trubrics. I've already got Trubrics installed, so this is going to be a bit quick for me. And I've also previously created a virtual environment that I'm going to run this tutorial from. So the first thing we're going to do is have a look at the model validator, and we're going to basically build some validations on the use case of the Titanic. So I'm going to go ahead and open an IPython kernel where we're going to do this. So let's first import some modules from the Trubrics SDK. First, we've got a data context, which is basically our data object where we're going to group all of the ML data sets into a single object that can be used by both the Trubrics SDK model validator and the feedback collector. Secondly, we've got a function here that allows us to get some data, so it's a test data set from the Titanic use case, and that's going to train also a model for us. Here it's a random forest model that we're using today. Lastly, we've got some objects from the Trubrics validations. So here we're importing a model validator, which will allow us to build some validations, specifically out-of-the-box validations. And then we've got a Trubric object, which will allow us to group these validations into a single object. Let's import our data and our model. So here, let's just have a quick look. This is the classic Titanic use case data set. So nothing too special there. Let's have a look at also our model. So here we're going to use our model to predict on the test data set just to make sure that everything's fine. And as you can see, we've got an array output predicting 1 or 0 whether a passenger has survived or not. Now we can go ahead and create our data context. So like I said, it really wraps any data that you would use in a machine learning pipeline into a single object. Here, to get started, we're just using a testing data set and the target variable. You can obviously include training data sets or other data sets that you would like to use in the future for validations, but today we're just using the bare minimum. Here, so that our testing data variable is always a pandas data frame. Here I'm just feeding in the test df that I've loaded previously. And I'm specifying that the target column within that test df is the survived column that you can see right here. So the next thing we're going to do is create a model validator. So the model validator takes at a minimum 2 things as an input. So the data context that we've previously just created, and then also a model. This model can be anything from up to scikit-learn to a custom model. You can check out loading in custom models to the model validator in our docs. And then once we've instantiated this model validator and we've created an object, we can go ahead and build some out-of-the-box validations. So here what I'm looking at is creating 2 out-of-the-box validations. The first one is a simple performance validation. So it's validating that the performance is above a given threshold. So here we're looking at accuracy specifically, and we're making sure that that accuracy value of our model is superior to a threshold of 0.7. And so we are calculating the accuracy of our model directly within the model validator, and then just checking that that's above a threshold. The second validation that we're going to do is a feature importance validation. So here we're validating that our feature age is in the top n important features, so specifically the top 3 important features. And to calculate this feature importance, the model validator uses permutation feature importance. So here we have a log that says that we are computing the permutation feature importance for the testing data set with 10 permutations, so on 10 different shuffles of each feature. So that looks like that's all run. What we can do now is have a look at some of these validations. So in the list, we're going to have a look at the first element. And here you can see it's a validation object. So this is actually a pydantic data model. The best way to look at that is to kind of use the .dict method, so we can convert it directly to a dictionary. And here we've got a number of things that we can look at. So we'll first of all storing the validation type, which is just the name of our method. Also, we store the quarks that we used, so the metric accuracy, the threshold of 0.7. And then we have an explanation key, which holds the docstring of our method. So this is useful if you want to display kind of what exactly is going on in this method on a user interface. Then we have an outcome, which is a pass or fail. So here we've achieved a performance of 0.79 and our threshold is 0.7, so it's passed. And severity that can be actually passed in to each validation as a separate argument. In the results is just a dictionary that allows us to show the user any metrics that have been calculated during that performance or during that validation. The next thing we're going to do is save these validations as a trubric. So a trubric, like I said before, already groups our validations into a single object. We can specify all sorts of metadata for this. I'm just specifying the minimum, which is a name for the trubric. Here I'm also feeding in the data context name and the data context version. So you've noticed that I haven't actually used a name or a version in this data context. Here we're just using the default values that are set. And also we're feeding in our validations list that we've compiled just above here. So once we've done that, we can call a method called saveLocal directly on this trubric, and that allows us to save this as a local JSON file. Here we've got the log indicating that it has saved, so we can go ahead and have a look at that directly. So this is the trubric that has been saved with both of our validations in. So like I said, we have here some metadata, like I described before. You can also track some model metadata, like a model name and a model version. And here are our two validations. So this is the validation that the performance validation that we just went through, and there's also the feature importance validation here that also passed, as age has an actual ranking of 2, and we've set a top end features argument of 3. So there you have it. The next thing we're going to do is I'm going to show you really quickly how we can actually run that trubric against another model and another data set. So this is really useful for when you're in continuous training pipelines or CI/CD pipelines, and you've created a trubric or a list of validations that you want to run against a new model that you're pulling in, that you've just trained, for example, or even a new data set that you've just collected in sort of production environment. So here I'm not going to go into too much detail about this. I'm going to leave that for another day, but we have a trubrics run command, which is a CLI tool that we can use. And the thing to note here is that I'm passing in an argument of my new trubric.json, which is the file where I want to save the new trubric. I'm going to go ahead and run that. And here it's basically running exactly the same two validations that we've just built in the previous step. This is taking a bit of time because it's recomputing the feature importance based on that new model and on that new data set. So here we can see that we have our trubric that we created previously, and we've got the output also of the new trubric that we've just run against. And so here in this new trubric, the difference will be in the outcome. If any have failed, it will obviously be failed, and we will see the new results of any metrics that have been computed during that validation. To learn more about our CLI tool, or even have a look at the full tutorial on the Titanic dataset, you can refer to our docs. Here we've got an IPython notebook that is containing loads of out-of-the-box validations and a full example of how also you can create custom validations as well. The next thing we're going to be looking at is the feedback collector. So this is useful in allowing data scientists to build a quick web app around a model and a data set that will allow them to collect feedback from business users. And so at Trubrics, we really do believe that collecting feedback is an essential part of building good validations. It's very common that the data scientist has the technical knowledge, but then the kind of business and domain knowledge is held within a couple of users or within some business users. And so a lot of the time as a data scientist, we're trying to extract that knowledge and put that knowledge, inject it into our models. And the feedback collector is going to help you do that. So I'm not going to go through each of the individual code snippets here, but what I will do is I'll run our out-of-the-box example, which is again an application on the Titanic use case. You can run this directly out of the CLI tool with Trubrics example Titanic app. This will open the Streamlit application. So again, this is something that you would like to put in front of users, and it will allow them essentially to play around with the inputs of the model and see the influence that has on the model's prediction. So for example, on the left in the sidebar, we have a series of all of the features of the model. We can see that if we change one of these features, we can see that that has a direct impact on the model's prediction. And so the whole goal of this application is that we're really trying to give the business user the relevant tools to be able to probe the model and to try and find errors. So once they've seen something that looks kind of a bit strange to them, for example here, all I did was change the title from Master to Mister, and I see that the model prediction has changed, which probably shouldn't happen. Maybe means that our model is not dealing with the title feature really that well, and so as a user, I'm just going to explain that to back to the data science team. Another feature that we have within our Streamlit application is the ability to view the full data set or to view some specific errors from that data set. So this can give the user some ideas of things that they can look at specifically and some inputs they can play around with. And maybe they have some insight into why the model is wrongly predicting some of these data points. So the goal here, once we've collected a whole load of feedback from our users, is to convert that into custom validations, and down the line of the model and through the lifetime of the model, it will always be tested against those custom validations. And so all feedback that is given at this stage, even if it's during the first couple of weeks of model development, that feedback is translated directly into custom validations, and it's really tested repeatedly throughout the model's lifetime. So thanks very much for listening to this Getting Started tutorial. I hope to see you soon, and don't forget to check out our repository on GitHub and our documentation.